So welcome in this video, and our main motto to understand is there is need of more work in actual process of a compression, right? In ideal process we need less work, and so I have like tried like just fashion. Compressor need more work in actual cycle. Why? Work done for actual cycle is greater than work done for ideal cycle for a compressor. So this video is going to give you clear cut idea about this kind of basic doubts, okay, for the beginners. And you might be knowing this. You see on T's diagram, we are talking about a compressor. Suppose this is a symbol of a compressor. Compressor takes some amount of air at certain pressure, and outlet at the outlet pressure will be more, right? That is the meaning of compression, right? So suppose here we are talking about pressure P01 and here pressure P02. So definitely P02 has to be greater than P01 because we are compressing the air. Okay, so to compress the air, compressor needs some work. Okay, so that work in ideal compressors are less, and that work in actual compressors are more. But why? Okay, so main logic is because of irreversibility present in the compressor device. Fine. Now question comes, what happens if irreversibility is there? Okay, so see, this line represents P01 pressure, which is at the inlet of compressor, and this line represents P02 pressure, which is at the outlet of a compressor, inlet and exit. Fine. Now at the inlet, suppose you have temperature, this temperature I am saying as T, and if you will go ideally, that is isentropic process, you will reach here and you will be having temperature this, but in actual process you will end here and you will be having more temperature, right? Okay, so in this video we are going to discuss why so this part gives us, this part gives us actual work and this part gives us ideal work, right? If I'll give the symbol T1, T2, T3, so definitely efficiency of a compressor is going to be T2 minus T1 by T3 minus T1. But question comes again, why we have to supply more work in actual compressor? I hope what is the doubt? The doubt is very clear. Now I will explain. So if we have any actual compressor, then there will be irreversibility available in the device, right? Irreversibility means there will be friction, there will be heat transfer, So suppose to compress the air from P01 to P02, in ideal case, suppose you want some 100 joule work per second, okay? But in real life, what happens in actual process? What happens? Some amount of work out of this work, suppose 10 joule, will convert into heat when 100 joule work will enter to the device. Some 10 joule, just an example, will convert into heat, and that heat will go out. Okay, in ideal case there is no reversibility, so your 100 joule work will be properly available to compress this air to this temperature, to this pressure. But in real life your 10 joule work will be wasted as a heat, and this heat will go out in the atmosphere. So this heat has no value. You are not going to use this heat, right? So 10 joule work you are losing. This is work loss, like loss of work in irreversible process. I am trying to explain whatever work is available to compress the air from P01 to P02, in ideal case, that I have considered as 100 joule. Now I am saying in actual process, if you want to convert P01 to P02, you need 100 joule work. But because there is presence of irreversibility, means some amount of work out of 100 joule, suppose 10 joule, this 10 joule work will convert into heat, and that heat will go out of the device. So that is of no use. This 10 joule work is loss. right? This is our loss. So to overcome this loss, you need to supply 10 joule more. So now your total work input is 110 joule. You see, in actual process, now we have to supply 110 joule. I hope it's been clear. So this is the basic idea. In actual process, irreversibility is present, friction is present, and whatever work you will supply. So that same happens in turbine also. Suppose this is the turbine, and at the inlet of the turbine you have some pressure, suppose some P04, or you can take at P03, and after the expansion you will be remaining with less pressure, that will be P04 because of expansion. So turbine will give you some work, right? Suppose in ideal case turbine is going to give you 100 joule work, but actually in actual case some amount of work out of this 100 joule, suppose 10 joule work, will be lost again because of irreversibility present. And how, in what phase we are going to lose this work? This work will convert into heat because friction is present and blah blah things are inside. So this heat will go out of the system, which is again has no value, zero value. We are not going to use this work, this heat. That's why when you will touch the device, it will be some kind of heat up, right? The device, when you will touch the device, it will be heat. There will be heat on the surface. You can feel the temperature, right? So you will not be getting 100 joule. You will be getting just some 90 joule. That's why when you will draw the turbine, so again on TS diagram, this will be your more pressure, suppose P03, and you are going to achieve some other pressure P04 after expansion. So this will be your ideal work, and this will be your actual work, right? So this actual work is actually less. Okay, don't worry about the graphs, go for the idea just. So your actual work will be less, because if ideal work is 100 joule, this is going to be just 90 joule, because 10 joule you have lost. I hope it's clear. That's why when we find out compressor efficiency, always keep in mind efficiency of compressor or efficiency of turbine, they both has to be less than 1, correct? I mean in decimal points less than 100%. So in decimal they both has to be in decimal. Decimal means your numerator has to be less than 1. Sorry. Your numerator has to be less than your denominator. So your denominator has to be more. So in case of compressor, what should be in denominator? Ideal work. And what should be in numerator? I'm sorry. What should be in denominator? Actual work, because actual work is more. We are talking about compressor, efficiency of compressor. That is, you can say isentropic efficiency. And your ideal work will be less, no doubt. But in case of turbine, if you are finding out efficiency, again numerator and denominator concept you apply, it should be less than 1. It means this value has to be less than this value. So if this value is less, it means this is actual work. In case of turbine, this is actual work, right? And ideal work will be in denominator. Let's repeat once more. Efficiency we are going to find out in case of compressor, then your numerator has to be less than your denominator. Either you talk about compressor or you talk about turbine, does not matter. In both the case, same logic. So which work you are going to put up and down? Keep in mind, in case of compressor, actual work is more, so more value you keep down, and ideal work or isentropic work you keep up. And here your ideal work is more. Just now I have explained, and your actual work is less, because final answer has to be less than 1, because we are talking about efficiency. I hope this explanation is somewhat clear for you. Okay, you can like or dislike, no problem. Thank you.